Back titrations. So, welcome to back titrations. Today we'll go through what a back titration is, how it works, and why we use it. So what exactly is a back titration? Alright, let us picture this. You want to titrate something, but it doesn't want to work. So instead of fighting it directly, we use the A-level chemistry equivalent of pouring too much acid on it intentionally. In this case, we add the excess reagent, let it react, then measure how much leftover stuff there is. From that leftover, we deduce how much reacted originally, like solving a murder mystery, but the victim is a mole of acid. This is basically how you carry out a back titration, by adding the excess, then allowing it to complete, titrating the remaining, and then using stoichiometry. So why do we use a back titration? Why do we do this? Because chemistry basically refuses to be simple. Sometimes a sample is really chunky piece of solid. And sometimes the reaction is so slow you can age about 5 years waiting for endpoint. Or my favourite reason is that the indicator just doesn't want to work with the reaction. So back titrations aid us in producing things such as calcium carbonate tablets, fertilizers, ammonia, and antacids. Basically anything that doesn't want to do the acid-base titration. The general method. Okay, this is the interesting bit. Step 1. You throw excess reagent A into your sample, like way too much than you need it. Step 2. The sample reacts with some of it. And step 3. You titrate whatever is left with reagent B. Then the magic equation will appear, which is that the initial moles minus the leftover moles is the moles that reacted with the sample. And then you have just unlocked how to solve this question. Key equations you must know. So the equations here are like our best friends. First, basic moles. Moles is concentration times volume. I know you all love. I know that all of you already know it, but EdXL still loves making you cry with it. Then the more important ones. Initial minus leftover equals whole actually reacted, and if percentage purity shows up, just remember that the real mass over the total mass times 100%. Simple like that. The flow chart. Here is basically a visual map. Think of it as something that basically shows how you hunt, like the steps, like a treasure hunt. But in this case, the treasure is the moles. So the sample, then you add the excess, titrate leftover, subtract, use the ratio, and then bin it. If you just follow this, you'll never get lost, unless you forget to convert centimeters cubed again. Exam tips. This is full marks time. Write the equations first. Convert the volumes. Use a table for the moles because it makes you look organized. And only round at the end, because rounding early can affect your results. Summary. Alright, so the main details is that back titrations isn't that scary. They are literally adding excess, titrating leftovers, subtracting ratio, and then you're done. Once you understand the pattern, every past paper question becomes real easy. Thank you.